There is a direction baked into your every waking moment, a thrust, a forward pull that feels so natural, so inevitable, that you have never once stopped to ask whether it is real. You remember yesterday. You do not remember tomorrow. You grow older. You do not grow younger. Coffee cools. It does not spontaneously reheat. Broken glass stays broken. And somewhere in the background of all of this, you carry a quiet certainty that time has a direction, that the universe is moving forward, that the arrow of reality points from the past into the future. But here is the thing that every equation in fundamental physics is quietly whispering to anyone willing to listen. That arrow is not written into the laws of nature. It is not a feature of the universe at its deepest level. It is a thermodynamic illusion, one constructed entirely by the behavior of matter in states far from equilibrium, one that dissolves completely when the engine driving it shuts down. Let us begin at the foundation. Take two billiard balls rolling across a table. They collide, they scatter. Now film that collision and play the footage backward. What do you see? Two billiard balls rolling across a table, colliding, scattering. You cannot tell the difference. The backward film is physically indistinguishable from the forward film because the underlying equation governing that collision, Newtonian mechanics, is perfectly time-symmetric. Run the mathematics forward in time, run it backward in time, the same equation holds with equal validity. Newton did not write a law that said events must proceed in a specific temporal direction. He wrote a law describing forces and accelerations that is completely agnostic about which direction time flows. And the same is true at the quantum level. The Schrödinger equation, the equation that governs how quantum states evolve, is time reversible. If you have a solution that describes a particle evolving forward in time, the time-reversed version of that solution is equally valid, equally permitted by the mathematics. The laws of quantum mechanics do not point at the future and say, that way. They simply describe how physical states relate to each other without any preferred temporal direction built in. This is not a minor technical footnote. This is a profound statement about the architecture of reality. At the level of individual particles, individual quantum states, individual fundamental interactions, time has no preferred direction. Physics is symmetric under time reversal. Forward and backward are mathematically equivalent descriptions of the same physical processes. So then why does your life feel so unambiguously directional? Why do you age instead of de-age? Why does an egg shatter and never reassemble? Why does heat flow from hot objects to cold ones and never spontaneously reverse? Why does your memory face backward into the past and not forward into the future? The answer to every single one of those questions is the same: entropy. Ludwig Boltzmann, working in the latter half of the 19th century, cracked open one of the deepest puzzles in physics. He understood that macroscopic objects, the egg on your countertop, the coffee in your cup, the body you inhabit, are not described by a single microscopic state. They are described by an astronomical number of possible microscopic arrangements and the macroscopic properties you observe, temperature, pressure, shape, reflect the collective statistical behavior of all those microscopic configurations. His formula, S equals K times the natural logarithm of W, captures this with devastating elegance. Entropy S is proportional to the logarithm of W, where W is the number of distinct microscopic configurations that correspond to the same macroscopic state you observe. High entropy means a vast number of possible microscopic arrangements producing the same outward appearance. Low entropy means a comparatively tiny number of configurations. Now think about that egg before it hits the floor. The yolk is separated from the white. The shell is intact. The internal structure is highly organized, highly specific, low entropy, a state achievable by a relatively small number of microscopic configurations. When the egg shatters, the shell fragments scatter, the yolk splashes, the proteins denature, and the system moves into a state that is achievable by an enormous number of microscopic arrangements. Broken, dispersed, mixed, high entropy. And this is why the video of the egg reassembling looks absurd when played in reverse. Not because the laws of physics forbid it at the level of individual molecules, they do not, but because the probability of all those scattered molecules spontaneously coordinating to reconstruct the egg is so astronomically small that it is functionally indistinguishable from impossible. The second law of thermodynamics is not a hard prohibition written into the fundamental equations. It is a statement about overwhelming statistical probability. Systems evolve toward higher entropy states because there are vastly more high entropy states than low entropy states, and random microscopic motion will therefore statistically drive any system toward maximum disorder. This statistical asymmetry is the source of the thermodynamic arrow of time. It is the reason that the macroscopic world looks directional, even though the microscopic world is time-symmetric. And it creates something remarkable in biological systems, something that makes living organisms profoundly different from scattered billiard balls. A living brain is a thermodynamic engine running against the current. Your body takes in highly ordered, low-entropy energy in the form of food and oxygen, processes it, extracts useful work, and expels heat and waste, higher entropy outputs. Your neurons fire in structured sequences. Your biochemical machinery maintains concentration gradients across cell membranes. Your metabolic processes sustain a localized region of stunning thermodynamic order, a low-entropy island in a universe relentlessly drifting toward equilibrium. And the cost of maintaining that order is a continuous, active consumption of free energy. You are not a passive arrangement of atoms. You are a process, an ongoing thermodynamic event, a system continuously doing work to hold itself far from equilibrium. And this active maintenance of low entropy order is precisely what generates your psychological experience of temporal direction. Your brain encodes memories because the process of neural encoding is thermodynamically irreversible. The act of forming a memory dissipates energy, increases local entropy in specific ways, and leaves a physical trace. You remember the past and not the future because memory formation is a causal, entropy-generating process that runs in the direction of increasing disorder. You perceive time as flowing forward because your entire cognitive architecture is built on top of a thermodynamic engine that is itself running in the direction of entropy increase. Your psychological arrow of time is the direct phenomenological reflection of the thermodynamic arrow of time operating inside your biology. Now consider what happens when that engine stops. The cessation of biological function is not merely a medical event. At its deepest physical level, it is the terminal phase of a thermodynamic trajectory. When metabolic processes halt, when neurons stop firing, when the concentration gradients across cell membranes collapse, when the continuous input of free energy that maintained the system far from equilibrium ceases, the body begins its irreversible drift toward thermal equilibrium with the surrounding environment. Temperature equalizes, chemical gradients dissolve. The highly organized molecular machinery of biology relaxes into the statistical ground state of maximum local entropy. The system reaches what physicists call thermal equilibrium, the state in which there are no remaining thermodynamic gradients to drive any further macroscopic change. Think about a thoroughly shuffled deck of cards. Before the deck was shuffled, it had order, low entropy, a specific arrangement. As you shuffled it, the entropy increased, moving through less and less ordered states. But once the deck is thoroughly shuffled, once it has reached maximum disorder, shuffling it further changes nothing at the macroscopic level. There are no more gradients of order to erode. The deck is at thermodynamic equilibrium with respect to its own arrangement. Further shuffling simply moves the system among the enormous number of high entropy states that are macroscopically identical. At that point, the direction of the shuffling process becomes meaningless. There is no arrow in the shuffling anymore because there is no remaining gradient between order and disorder. This is precisely the situation facing the atoms of a biological system that has reached thermal equilibrium with its environment. There are no more thermodynamic gradients to exploit. There is no more free energy to be extracted. There is no more entropy to be generated in any locally meaningful directional sense. The system has arrived at the state that the second law of thermodynamics was always driving it toward. And in that state, at the level of the individual molecules and atoms that once constituted the living system, the physics reverts entirely to the regime of billiard ball collisions. The atoms continue to move and interact, but their interactions are governed by the time-symmetric laws of mechanics and quantum physics, laws that carry no intrinsic directionality. Forward and backward become mathematically indistinguishable descriptions of the same physical reality. It is critically important to understand what this does and does not mean. The timeline of events does not literally rewind. The specific historical sequence of configurations that constituted the life of a biological system does not play itself backward like a film reel. What happens is more subtle and in some ways more profound. The forward thrust, the directional arrow that made that sequence of events feel sequential, that made moments feel as though they were succeeding one another in a definite temporal order. That arrow was entirely the product of an ongoing thermodynamic process. It was never a fundamental feature of the space-time fabric. It was always an emergent property of entropy gradients. And once those gradients are gone, once the engine that generated the directional illusion has stopped running, the physical reality of those scattered atoms no longer participates in any thermodynamic process that distinguishes forward from backward. For that physical system, considered on its own terms at the microscopic level, temporal direction has no remaining physical content. Roger Penrose has written extensively about the profoundly low entropy initial conditions of the universe, the extraordinarily special state from which the Big Bang emerged, which seeded the entire cosmic history of entropy increase that we inhabit. The cosmological arrow of time, the direction from the Big Bang toward maximum entropy, is the ultimate source of every other arrow of time we observe, biological, psychological, thermodynamic. We exist and we experience temporal direction because we are embedded in a universe that is still very far from its final equilibrium state, still burning through the extraordinary thermodynamic inheritance of its low entropy beginning. Every process that feels directional to us, from the formation of memories, to the growth of organisms, to the evolution of stars, is a local manifestation of this cosmic gradient from order to disorder. Now, here is the conceptual piece that genuinely expands the boundaries of how physicists think about time and existence. The condition of maximum entropy thermal equilibrium is a state with no distinguishable past or future at the local level. This is not a poetic statement. It is a direct consequence of the mathematics. Consider a gas of molecules in a sealed container that has reached thermal equilibrium. The molecules are bouncing around, colliding elastically, completely time-symmetric interactions. If you took a snapshot of that gas and tried to determine from the physics alone whether time was moving forward or backward, you could not do it. The system looks identical in both temporal directions because it is at maximum entropy. There is no gradient left to distinguish the two. The system has, in the precise thermodynamic sense, lost its arrow. This has implications that physicists continue to grapple with in the foundations of statistical mechanics. The concept of the Boltzmann brain, the possibility in a universe of eternal thermal fluctuations, of spontaneous low-entropy fluctuations assembling themselves briefly into organized structures, including observers, is a direct consequence of this time symmetry at equilibrium. In a universe at maximum entropy, rare fluctuations into temporarily lower entropy states are equally likely to fluctuate toward that lower entropy state from either temporal direction. The physics genuinely does not prefer a direction. This is one of the reasons that Boltzmann himself struggled deeply with the philosophical implications of his own statistical framework toward the end of his life. The statistical mechanics he built was powerful enough to describe why we experience an arrow of time, but it also revealed with unsettling clarity that this arrow is not written into the fundamental laws. The connection between information and entropy deepens this picture further. Claude Shannon, working on information theory in the middle of the 20th century, discovered that the mathematical structure of information entropy is identical to Boltzmann's thermodynamic entropy formula. The entropy of a probability distribution over possible messages is mathematically equivalent in form to the entropy of a probability distribution over microscopic states. This is not a coincidence. Information and thermodynamic order are two faces of the same physical reality. A highly organized biological system is also a highly information-dense system. Your brain stores and processes information precisely because it maintains thermodynamic order, low entropy structure, against the relentless statistical pressure toward equilibrium. The thermodynamic cost of erasing one bit of information was calculated by Rolf Landauer and is given by k times t times the natural logarithm of 2, where k is Boltzmann's constant and t is temperature. Erasing information is a physically irreversible process that necessarily dissipates heat and increases entropy. Memory formation and cognitive processing are thermodynamic events. They have a physical cost, and they run in one direction. When that information processing architecture ceases to function, the tight coupling between thermodynamic directionality and psychological temporal experience is severed. The atoms that constituted the cognitive machinery are still physically real. They continue to participate in the ongoing physical processes of the universe. But they do so as components of a system that has rejoined the vast entropic background, a system no longer maintaining any internal gradient that privileges one temporal direction over the other. Their interactions are now described with full fidelity by time-symmetric equations. The forward thrust of thermodynamic time, experienced so vividly throughout biological existence, simply has no more physical grip on a system that has achieved equilibrium. There is a version of this understanding that the physicist Julian Barbour has pushed to its most radical conclusion. Barbour argues that time itself, as a fundamental feature of reality, may not exist at all. In his formulation, what we call time is entirely a consequence of the correlations between different configurations of the physical world. The sense of temporal flow is not the universe moving through time. It is the universe existing in a configuration that contains within it the records and structures that brains interpret as memories of a past. On Barbour's view, which remains contested but seriously discussed in the foundations of physics, there is no river of time carrying us forward. There is only a landscape of possible configurations, some of which contain within themselves the impression of having arrived from somewhere. Whether or not one accepts Barbour's radical position, the core physical message from the thermodynamic analysis is clear and supported by every branch of fundamental physics. The directionality you experience is thermodynamic in origin. It emerges from entropy gradients. It is maintained by biological engines running far from equilibrium. And it dissolves at the level of the underlying physical reality when those engines reach the equilibrium state toward which the second law of thermodynamics has been inexorably driving them all along. The universe, at its mathematical bedrock, does not distinguish yesterday from tomorrow. The billiard balls of fundamental physics roll in either direction with complete indifference. What we call the arrow of time is a magnificent, improbable, thermodynamically expensive achievement of matter organized into the extraordinary structures we call living systems, sustained against the current for a cosmically brief interval, and then released back into the symmetric, directionless ocean of physical law from which it briefly emerged.